Hello everyone. Today I am going to explain about prediction using supervised machine learning. The given problem statement is predict the percentage of student based on number of study hours, which need to be solved using simple linear regression. Using Python, I am going to solve the problem. This problem is going to solve using simple linear regression. What is linear regression? Which is linear regression helps to find the relationship between x and y axis, which is also called as predictive model, which can be found using many methods. In that I am using least square method to solve the given problem using the given dataset. Important formulas to solve using least square method. To find slope or gradient, m is equal to summation of I equal to 1 to n xi minus x bar the whole into yi minus y bar divided by summation of I 1 to n xi minus x bar the whole square. Find y intercept or bias, which is equal to y bar minus m into x bar, where y bar and x bar of mean of x and y, and xi and yi are iteration of x and y using summation. Before we are going to solve using Python, let's go for Excel to know more about the linear regression using the given dataset. Here, which is the given dataset, and then we have found regression using Excel, and we have find the R square value as 0.952948197 and adjusted R square as 0.950, and then we are finding slope as 9.7758 and 2.4836, and then we are finding the coefficients, standard error and statistic p-value lower than 95 and upper than 95, and we are obtaining the predicted y and residual, which means we are predicting the value of y, and we are finding the residual of predicted y to resolve the errors in the given while training the model. Here we are plotting the scatter plot, and then we are plotting the regression line using y equal to mx plus c, which is 9.7758x plus 2.4837, which is the regression line, and the points are and the scatter plots are pointed using given dataset. We have found slope, y-intercept and r-square values, which is exactly the same while implemented using the Python. Here we are importing the modules of as Python, NumPy and Matplotlib, and then we are extracting the dataset as read CSV model function, and then we are printing the dataset using a data frame function, and then we are obtaining the rows and columns values as df.shape, and we are storing the column values as n for further calculations, and then we are separating the tables as x and y, where x is equal to time and y is equal to scores, and then we are plotting scatter plot using matplotlib function, and then we are finding the x and y mean values using numpy, and then we are storing numerator and denominator as 0, and then we are iterating using for loop, and then we are we are applying the value of m using numerator value and denominator value, such as xi minus x mean, which is x bar, star yi minus y mean, which is y bar, and the denominator is equal to xi minus x mean, which is x bar the whole square, and then dividing numerator by denominator to obtain the value of m, and then printing the value of m and c. We have obtained the same in Excel, which is 9.7758 and 2.4836. See, we are obtaining the slope value as 9.7758 and 2.4836 in Excel 2. And then we are storing the y value as mx plus c using y predicted value, and then we are again using scatter plot for x and y using the dataset, and then we are plotting the regression line using a minimum of x and maximum of x as a one point, and minimum of y prediction and maximum of y prediction as another point, to plot the regression line, which is represented using a red color, and then we are obtaining the graph as seen. To finding the efficiency of the given model, the R-square score is calculated, which I am storing SS total and SS residual as 0, and then iterating using for loop for S total is equal to yi minus y bar the whole square, and SS residual is equal to yi minus y prediction the whole square, and then I am using R square as 1 minus SS residual by SS total to obtain the value of R square score, which is 0.95294, which can be obtained in Excel also, which can be shown R square is equal to 0.952948, shown here, and then we are obtaining y values, y predicted values by using x value as an input, by giving x as input and obtaining y as output. Let's run all the cells together. So that we are asking input for enter value between 2 to 8 hours. I am entering 4.7. We obtain the value as 4.48.429 as a score. So that we are obtaining R square score as 0.9529, which is the very best score, which nears to 1. Thank you to all.